Hello everyone, I am Professor Aher. In this video, we are going to see hybrid non-conventional machining process, that is a shape tube electrolyte machining process. Shape tube electrolyte machining is an electrochemical machining process. Work on the dissolution principle is mainly used to obtain smaller diameter depth hole. Also, this process is commonly used in aerospace industry to drill holes of high aspect ratio up to 300:1 in difficult to cut superalloys. It works under electrolytic principle. The anodic workpiece and cathodic tool are folded with the electrolyte, generally acid base electrolyte such as hydrochloric acid or sulfuric acid having 10% concentration in water is used in this process. In this process, the combination of chemical and electrical energy, the material is removed by electrochemical dissolution action. Figure shows a schematic of STEM process. The tool used in STM is a hollow shaped tube with an insulating coating on all over exterior surface except at the tip of the tool. A servo system is used to maintain a constant gap between tool and workpiece. A voltage of 5 to 15 is applied. The tape or the gap at higher voltage causes boiling of electrolyte, which eventually damage the electrolyte coating and hence affects the geometrical and dimensional accuracy. The tool is given with a constant feed value to maintain the constant machining gap. The feed rate is about 1.5 mm per minute. Using the STM process, small holes up to 0.76 to 1.6 mm in diameter with a high depth to the diameter ratio can be produced in electrically conducting material. However, it is difficult to produce such a small size and high aspect ratio hole using ECM and insoluble practices produced during dissolution process obstruct the electrolyte flow path. Further, the electrolyte is collected in the tank and which is again reused by pump, filter and heat exchanger arrangement. The pressure is calculated with the help of pressure gauge and again which is transferred toward the tool. The parameters which is directly affect the quality of the systems are: first one, that is a machining current. It should be maximum 600 ampere. Concentration should be 10 to 20% within the water. Next, temperature should be 35 to 40 degrees Celsius for sulfuric acid and 20 to 25 degrees Celsius for other. Pressure should be maintained up to 275 to 500 kilopascal. Voltage should be forwarded voltage of around 8 to 14 and required for maximum current. Reverse voltage is 0.1 to 1 time of the forwarded voltage. Next is a time. So for forward action 5 to 7 seconds and for reverse action 25 to 77 millisecond. Next is a feed rate, that is tool feed is around 0.75 to 3 mm per minute. Next is advantage. The smaller size hole are smaller as 0.76 mm having high aspect ratio of 300 can be produced. A multiple holes as large as 200 in the numbers having different size and shapes can be simultaneously drilled. The blind holes with small size, shapes and curved holes as well as micro slots can be easily produced. Next, using STMM tabulated non-parallel holes on difficult to cut superalloys can be obtained. These tabulated holes are drilled in turbine blades so as to provide more cooling area. No recast layer are metallurgically defected are produced. STEM being an electrochemical process eliminates the recast layer and a heat affected layer and work is produced air free from metallurgical defect and micro cracks are normally observed in thermal process such as LBM, EDM, etc. Next is a limitation. The process is only applicable to the machine electrically conducted and corrosion resistance material. The STM is more suitable to obtain multiple shaped and curved holes as process being very slow and not economically to drill a single hole. The STEM use acidic electrolyte and hence a special environment and corrosion resistant machine components are required. A special care is required to take to dispose hazardous waste and last is a special type of tooling is required as the process is complicated comparing with the other process such as LBM, EDM and PAM process. Next point is a application of the system. Here the first the circular and shaped holes for cooling purpose in turbine engine airfoils. Next, fuel nozzle for gas turbine and jet engine parts. Next, for holes where metallurgical defects and micro cracks are not desirable. Also for drilling initial holes for wire EDM process. Also it is used for drilling small size and shape holes for which is difficult to cut superalloys and corrosion resistance low machinability metals such as stainless steel. Next application is for production of oil holes in bearing and last one is drilling of tabulated holes in a turbine blades to enhance the heat transfer coefficient. Thank you. Thanks for watching.